Since Einstein, the speed of light has been considered as the cosmic speed limit of the universe. Einstein stated that no object with any amount of measurable mass can travel faster than the speed of light. A particle, a photon, or a particle of light can travel at about 300,000 meters per second.
Gee willikers, that's quick!
But could Einstein have been mistaken? Is it possible to travel faster than the speed of light? Modern physicists believe it may be so. But in order to take advantage of faster than light travel, we must first find a better method for getting into space. What if we could take an elevator into space? Even though this may seem like science fiction, it one day may be regarded as science fact. Instead of wasting energy on the iconic blast-off of space missions, future astronauts may simply take an elevator ride to the heavens.
Right now, about every pound that's shot into space costs about $10,000. But with the use of a space elevator, that would decrease by a factor of 100. That was a cool noise. But how will we build a space elevator? A large satellite would be anchored to a fixed point on the Earth's surface. This kind of orbit is called a geostationary orbit. A satellite on the very fringe of space, 100 kilometers high, would travel at 3,139 meters per second to maintain a geostationary orbit. Using the equations for tension, Ft being tension, equals mg plus ma, and centripetal force, A equals velocity squared over the radius of the cable, we can calculate the tension of the cable to be approximately 50 million newtons.
50 million newtons is an unbelievable amount of force, and any cable put under that kind of tension would snap. However, we've recently discovered a new structural material known as carbon nanotubes. We've always known carbon can arrange itself in hexagons, but we've recently learned that these hexagons can then arrange themselves into tubes that are stronger than even a stainless steel cable. The only bad part is, the current world record for the length of a carbon nanotube is 3 centimeters long. On the bright side, only 999,999,997 centimeters left to go.
Zam! One of the first findings that led physicists to believe that the speed of light was not the ultimate speed limit was the phenomenon known as quantum entanglement.
Quantum entanglement occurs when two particles, usually electrons, become entwined so much that you can't refer to one without referring to the other. This means that whatever happens to one particle innately affects the other. This effect can last even over great distances.
Now, if you reverse the spin of one particle, the other particle's spin would instantaneously change regardless of distance. Now, even though quantum entanglement sends information faster than the speed of light, no discernible information can be relayed. For instance, you cannot have a conversation with someone via quantum entanglement.
The simplest forms of faster-than-light travel involve slow but steady acceleration over time. The most plausible method for nearing FTL speeds is called laser jet propulsion. This theory relies on the small but significant thrust lasers give off in a vacuum. Even though the thrust is incredibly small, only about 1/100th of a meter per second squared, exerting that force over an elongated amount of time can bring you to about 40% the speed of light.
Another idea of FTL space travel would be the idea of a solar sail. In space, the spacecraft would eject this massive sail. Due to its unbelievable size, of course, the sail would have to be constructed in space. The idea of this sail is that even though the mass of one photon is almost negligible, the idea that trillions upon trillions of photons hitting the sail could generate a force enough to accelerate the spacecraft. Of course, there are some problems to the solar sail. First off, it had to be the size of a planet. Humans had never attempted to build or construct something of that magnitude. Also, once it leaves our solar system, it would require some sort of laser or light source, since it uses that as energy.